Welcome everybody to this session. I'll start off by giving you a little introduction to who I am. Paul gave you a little bit of an overview there. I have been kicking around the business/technical world for many decades. I started off in the scientific community, got involved in artificial intelligence, wound up in the early 1980s working as a researcher and developer in a startup AI firm in that particular AI wave. And then I discovered I had perhaps unfortunate talent for management, and I wound up becoming a project manager. And I spent a lot of years doing project management on these kinds of projects. And I was always an early adopter of different kinds of technologies, from quality management systems to automation to early databases. We had deployed some of the first relational databases. And one of the things that I always looked at was what would be the advantages of automation, because we never had enough resources to get the job done. And there were so many problems that I would call black slack problems. The idea that we have a meeting and the programmers are going to go over their code for us, but they can't find the code. They think they may have left it in the back of their car, or maybe it's on a disk drive somewhere. And I would slowly go into the other room and beat my head against the wall, thinking there's got to be a better way to do this. We looked at a number of development methodologies, and then I spent some time getting out of project management and going around consulting with a lot of different companies and doing training in everything from major defense contractors to Wall Street firms at the heyday of Wall Street. And I keep telling people I was never the smartest person in the room, but I got a chance to see what the smartest people in the room were doing. And I basically use that as an idea in my training to tell other people what smart people do. Now, in terms of continuous integration and delivery, I've been doing this my whole life, not my whole life, but for many years. And one of the things that uniquely qualifies me to do this is that to do the seminars, I've actually done it. And in the course of doing it, I have been successful, but I also have made every single mistake it's possible to make in doing this. So I speak from the battlefield and the trenches. So that's what the basis of this presentation is about. What I want to talk about is broken down into these main topic categories, defining what continuous integration and delivery is. That's a bit unclear for some people. What we call the tool chain challenge, and then step back and look at it from a business perspective and say, okay, well, so what do we actually do? How do we actually leverage or take advantage of continuous integration and delivery? It seems to be a competitive edge that people are talking about, but how do we even approach the problem? And so we'll talk about that fundamental step, and then we'll talk about what the types of tools are that are out there that are involved in this. Now, I'm not going to go through all the tools. There's hundreds of them, but we're going to take kind of a representative of what each of the major tools are in each category, or just one of the representatives, and describe a little bit about what it does and how it fits into everything else. And then we're going to talk about something that's actually fairly important, which is called continuous testing. And then we're going to finally close this up and say, so how do you go ahead making a decision as to what to do? The first thing is that people get confused with continuous integration and continuous delivery and deployment. And they keep thinking, oh, that's a DevOps thing. So, we're talking DevOps. We're not going to go to DevOps. We don't need to do this because we're not a DevOps shop. Well, that's not really a DevOps thing. DevOps is more of a role-based, redefining the roles that people have on teams. DevOps tries to merge the kind of technologies, approaches, and expertise of QA, Ops, and Dev, which would give us DevOps. I know we don't have QA in the term DevOps. We're going to come back to that and point out that's fairly important. So people say, well, it's an agile thing. Not really, because agile is about a development process where you focus on getting things done, whereas DevOps is focused on highlighting roles and organizing teams differently and doing continuous delivery. But both of them rely heavily on the techniques of continuous integration and continuous delivery. So CI/CD is not an agile thing. It is not a DevOps thing. And that's confusing because both of them rely very heavily on it. But it also means that other kinds of paradigms and approaches and business models also rely very heavily on CI/CD, or can rely. So what do we talk about in process automation? That's what this is really all about. Well, in one sense, what we're seeing now is exactly what we saw in previous generations. The invention of the assembly line, the industrial revolution, the computer revolution. There have been these processes of automation. Some of you may be old enough to remember steno pools or secretarial pools, where all of the word processing was done by legions of young ladies. At the time, it was they were just the young ladies working on manual typewriters, carbon paper, and onion skin. And then the word processors came along, and if you can find a steno pool anywhere in the world at this point, you're probably looking at some kind of archaic village that time forgot. So we are seeing an inevitable change in how we do things through automating certain kinds of things and certain kinds of tasks. And so there's similarities there. It also means we can learn lessons from there. From my point of view, one of the most important things about process automation is improving process efficiency. There are so many places in a process where we can drop the ball. We can make mistakes. There's human errors. Oh, I misfiled that. Was I supposed to do that? I didn't know you checked the code in. How am I supposed to know that the code's ready for delivery? You forgot to email me, or these sorts of issues. I call these black slack, because this is the slack time that comes into a project that you don't anticipate. You know, when I was running projects, I had a programmer who couldn't find his car. He couldn't remember where he parked it. So he had problems finding where his code was. And what was supposed to be an integration that took an hour took 2 days until John could find his code. So what happens is that automation doesn't get tired. It doesn't make silly mistakes. Its attention doesn't wander. It continues to do work relentlessly, just like an assembly line in a factory. So I can automate all of that intellectual grunt work, all of that stuff where people drop the ball. My process suddenly becomes more efficient. It doesn't make the process better in the sense that it does better things. It just means I'm cutting out all of the places where it can go wrong. To make the process better and make better things is process effectiveness, which unfortunately we can't automate at this particular point. Now, the difference between that is if I'm booking a trip from, let's say, New York to Springfield, it's effective if I get to the right Springfield. So if I get to Springfield, Missouri, and I was supposed to go to Springfield, Massachusetts, not effective, no matter how fast I got there. If I get to the right place from New York to Springfield, Massachusetts, but I go via Los Angeles, Phoenix, and Bogota, Colombia, it's effective. I got to the right end, but I sure wasn't very efficient in doing it. So the idea here is that the whole notion of process effectiveness and process maturity is out the door. That's not what we're discussing here. We're discussing about getting rid of this black slack, the places where people drop the ball. We want the process automation to pick up the ball and run with it. So it enhances our capability to do work. The other thing about it is that it's process agnostic. You can automate any process. It doesn't have to be a DevOps, doesn't have to be agile. You just look for the places where you get the where you can replace human activity with some kind of automation tool. But that also means you can make bad processes worse. Garbage in, garbage out. Martin Fowler, great comment. I tell people all the time. They say, "Oh, we're going to automate and everything will be great." And I say, "Nope, a fool with a tool is still a fool." And I think Mitch Hedberg summarized that. He said, "Computer lets you make more mistakes faster than any invention in history, with the possible exception of tequila and handguns." And when I've watched organizations basically turn their go through what they called an automation, but the process was so bad that they added chaos on top of chaos until they were actually almost non-functional. But we get a lot of marketing and we get a lot of salespeople and a lot of gurus telling us, well, you just need to get a tool chain. We'll get this verified tool chain in there. So just deploy the tools and everything will work. Well, that sounds good in theory. It looks clean. It looks elegant. But then you suddenly find out and you look out in the wilderness and you say, oh my gosh, where do we even begin? I mean, we can see we've got a process where we've got a bunch of people working together and doing the coding. Then we build the product, we test it, we deploy it, and we run it. But how do we figure out what we do here? Okay, so this is an artifact of the fact that this was never developed in a systematic way. These various vendors who created these All were trying to solve a particular problem, and they decided to solve something else along with it. So we have something like GitHub, which can do build management, but Maven can also do build management, but Grunt can do build management. But they all came out of different communities of developers who wrote products to meet their particular needs, or develop these tools to meet their particular needs. And then they threw it out there. So as you can just go through, you'll probably find all kinds. There's Ant and Gradle and all these things, Slack, and all of these other things that are in there. So this is the first thing that people looking at this automation, because when you talk to a lot of the technical people, this is the thing that jumps out at you is, where do we even begin with this? And so let's answer that question. Bjarne Stroustrup, the inventor of C++, who is obviously one of the great technical gurus, kept reminding people that design and programming are human activities. You forget that and all is lost. So the single most important aspect of software development and automation is to be clear about what you're trying to build. So the starting point here is, what exactly are you automating? And this is getting more and more important as we talk about Grady Boosh. And if you look in your organization, you might discover that this prescient comment made back in the 90s says a lot of software has become mission critical. The organizations have become so dependent on the correct functioning of the software that if it fails, the operations of the business are seriously degraded. How many people can remember stories of a rollout of a new release and nobody could do any work because the release just broke everywhere in the organization? When software becomes that critical to an organization, it becomes what Grady called industrial strength software. It's so complicated and so vast that no one person can look at it and say, ooh, I understand how it works. At that point, we have to really start a collaborative process, and then we have to look at automating that collaborative process. So when we look at our collaborative process, we're going to say, well, what is this supposed to do for us? And this is one called the 4 pillars. And so we say code quality. Okay, so we've got to make sure that the developers are actually building code right, and they're building the right code. We've got to make sure that we can share these artifacts in various environments without manual intervention. So I don't have to copy to a shared directory that somebody can copy down. I shouldn't have to think about it. It should be out of my mind. And I also shouldn't have to constantly be thinking about code quality. There should be some way to automatically check that for me. There should be some way to do the testing. Did we actually build it right? Did we build the right thing? Is that what the users actually want? And then what we do is, once we deploy it, we want feedback to say, how are people actually liking it? How is it actually working out there in the field? These are the kinds of pillars that we want to bring into it. So the approach that we take is what's called application lifecycle management. And what this means is we look at a piece of software development as a product, and any kind of product. It starts with, is the same as the lifecycle management, say, in the military for a battleship. You have to sit down and think, okay, why do we need a battleship? What are the requirements that the battleship is going to have? How are we going to build it? And then you go into a process of actually deciding you're going to build the battleship. And in software, most software developers say, well, once the battleship's delivered, we wash our hands of it. ALM says, no, we're not done yet. We've got to get that battleship to the Navy, and we've got to be able to establish service depots around the world that can service that battleship. We've got to be able to upgrade its systems. We've got to listen back to the Navy and say, it's a great battleship, but it's got the following problems. And then when we get the new battleship in, what are we going to do with the old battleship? How are we going to decommission it? We start thinking in terms of the entire life cycle of the product. And that's what continuous integration and continuous development does. It's not associated with Agile or DevOps or any of these things. And I said it's process agnostic because what it's really focusing on is, what is the life cycle of that product of mine? How is that product going to go from a gleam in our developers' eyes to eventually being replaced by version 2 of our next product? And that's the process we want to look at automating. How do we put all of this stuff together? It's, like I said, process agnostic. Let's go back and just remember revisit our DevOps loop again. And so we find a number of fairly standard stages when we're talking about actually working with the product. We've got to plan what we're going to be doing. We've got to build it. And then we've got to deploy it and do integration. So I'm building a new piece, but it's got to integrate into everything else. For example, everybody wants the new features. If you look at any of the software releases coming out for Twitter and Facebook, actually Facebook was an interesting case study for this, no matter what you think of them. Facebook was always interested in rolling out continuous integration of new kinds of products. And one of the things that worked really, really well for Facebook was they said, we're going to introduce these Zynga games. And this was a number of years ago, like Farmville. And it turned out that because they were able to do the integration smoothly into the Facebook platform, it boosted their market tremendously. So we're always going to think about, how do we build things together? When you fix something, how do I put it together with everything else? How do I combine the work of all these people who are doing this work for me? And then once I've got it deployed, or once I've got it built, how do I get it out to the customer? And that's called deployment. Now, there's two terms that are confused a lot in CI/CD. One is continuous deployment, and the other one is continuous delivery. And we distinguish it on the basis of a continuous delivery is when I hand it to the customer and I say, there, the software product is delivered. Continuous deployment is where I go into the customer site and I put it, install it for them, so that they just walk up to, when they walk up to the computer, they say, oh, we've got a new version. If you're using something like Firefox practices continuous deployment, because you'll suddenly get that message, Firefox has installed a new version. We have to restart Firefox for the changes to take effect. That's continuous deployment. Then it's going to be out in the user environment. Did we do a good job? Does it work properly? Is it a resource hog? What are people saying? How do people use it? And so we're in an operational environment, and we have to collect data about it that provides us continuous feedback that feeds into our next planning phase. So the idea here is that this notion of this continuous development and this continuous deployment is something that we can only really accomplish with automation. So this is why so many people think continuous integration and deployment and development is DevOps, because DevOps can't exist without it. So it has become synonymous in people's minds that this is what we're doing. So for now, let's forget all these tools and let's just focus on this kind of process. You'll notice that in a couple of slides, I've got slightly different steps because people do conceptualize this process differently in different stages. Nobody's right or wrong, because you're going to see there's a lot of correspondence between them. So the first kind of tool we're looking at is going to say, well, somebody's got to be in charge of all of this. And often we call these orchestration tools, or we call these process managers. And the most popular one out there is called Jenkins. And there's probably a really, really cool story why it's called Jenkins. I just don't happen to know what it is. And so what Jenkins does is its job as a choreography tool or an orchestration tool. Its job is to link together all of the different tools and to ensure that they all interact with each other at the appropriate time. And this is done through what we call a series of events. So for example, Git is a repository. This is where my programmers are putting their code. And generally, we have a mechanism in here when their code is finished, they check it into their version control system. And when everybody has checked all of their corrected code and all of their tested code into the version control system, a message is sent automatically from the version control system to Jenkins to say, hey, we're ready to do a build. Then Jenkins goes and sends a message to Maven and says, hey, Maven, it's time to build the code. Maven builds the code and sends a message back saying we're done. And then we're going to call the continuous testing and say, okay, there's a new build. Let's run it through continuous testing. And so we do the testing. That test come back and say, hey, it all works great. And then we say, okay, so now we've got something to deploy. And so we're going to need some kind of tool to get it out there, and Puppet and Ansible are both two very similar things. And so we'll call for a tool like Ansible to go and deploy that new product out into our customer base. And then once we do that, we'll get a message back to Jenkins, which says we're set. By the way, what the configuration management tool here is doing is going to figure out how to actually configure things for deployment. So as each one of these steps is finished, they notify Jenkins and say, we're done, go on to the next stage. So now Jenkins goes and says, great, the deployment's done. Let's call Nagios and say, all right, now you're going to monitor that thing completely. And that cycle repeats next time when we've got Git coming in the next release, and we go through this process again. As we can see, the value to having this automated here is that Jenkins isn't going to drop the ball on us if we've configured it correctly. And I'm going to underscore that, if we've configured it correctly. One of the most common mistakes I see in automation is not taking the appropriate time to, number one, define the process you're operating and where all the hands-offs and the artifacts are supposed to go, and then misconfiguring Jenkins. So these things have to be tested. And the other thing we want to stress here is that if you don't know what your process is, you can't do this because you don't know what those handoff points are. So that gets back to point one. Make sure you've got your process intact and you understand it. That leads to an interesting side point, is that instead of automating chaos, what a lot of people do is take advantage of automation to step back and refactor or re-engineer their process, to say, we've got an opportunity to start clean. Let's go through our process and transform it into something that actually works and will automate the transformed process. This is an example of what we call the Git and GitHub workflow. And I'm just going to go through a couple of these tools now at this particular point. Hold on here. I was getting feedback. So this is the example we call collaboration. Git is designed so that everybody's got their own local code repository, but there's a central one that they all put their code in when they're done. So every time I'm finished a job in my local repository, I do something called a push. I push the code up to the repository. If somebody wants to see what I've just worked on, they pull the code back down. And then at some point, we'll basically say, okay, we've got everything is pushed up to the repository. That means we're ready to do a build, and we'll often go and create a copy of the repository, and then we'll go and start using that code in our testing cycle. Okay, so that's the notion of a collaboration tool. We're doing configuration. We're basically doing a document version control of some kind. We get control of our documents, but we also start to coordinate people's work so that there's a collaborative element to it, and we merge everybody's work, and there's a whole bunch of mechanisms to make sure that merges work correctly. So this is what we call a collaboration tool. It allows people to work on the same project locally. So it talks to, for example, it talks to Jenkins. So somebody says, okay, we've gone and finished. So what Jenkins does is it goes and says, ooh, okay, I'm going to check out the code. I'm going to create a copy of the repository, and then I'm going to call the build people or the build tool to build it, and then we're going to get the results of that back, and we're basically going to tell the people that checked in the code saying, hey guys, the build failed. You made some boo-boos there. Or we're going to say, hey, the build passed. It's not just building though. The other, and by the way, that when I'm saying a build tool, there's multiple build tools out there. Here's some of the really common ones. Rake in the Ruby world, Apache Ant, one of the old grandfathers, Maven, it's popular in the Java world, Gradle, which is also popular in the, I think it's the Groovy world. Again, these all come out of different communities. They all do fundamentally the same thing. Now we come to the thing of, okay, so we've got code, but how good is it? And this is a critical component that we like to be able to build into our development process. Most development processes are initially designed to build something, and quality assurance and quality control are testing are generally an afterthought when we suddenly realize, oh my gosh, we need to make this a lot better. Morris Beiser was one of the great gurus of software testing, and this is something I have up on the wall of every project I've worked on. It says more than the act of testing, the act of designing tests is one of the best bug preventers known. Because it forces you to think, well, what is supposed to happen here? The thinking that's done to create a test can discover and eliminate bugs at every stage in the creation of software, from conception to specification to design, coding, and the rest. And this is the part I always beat my developers over the head with. If you can't test it, don't build it. If you don't test it, rip it out. And that's important because then we want to automate that testing. So we're thinking about tests, we're building tests, and then what we're going to be doing is doing some kind of automated testing. And there's a variety of tools that do automated testing. One of the more famous one is a code inspection tool called SonarQube, which will go through, and after the code has been delivered, it'll go through the code and look for bad things in the code. In other words, what it's going to look for, so are possible errors, possible breaches, code quality, and it gives you an evaluation as to how good the code is by a number of standard rules. Now, the other thing that we can do is we can automate a whole bunch of other tools. So we've got Protractor, which is generally used in the JavaScript world, Selenium for interface testing, Test Complete, HP is Quick Test Professional. There's a number of test automation tools, but we have to design the test first. And then what we do is we automate what we're testing. One of the mistakes that I see a lot of people making, especially when they get into DevOps or Agile, they say, oh, we've got all these test automation tools. We don't need testers. Let's get rid of them. And the problem is that test automation tools don't test. What they do is they automate your test. So if you don't have tests to automate, these tools are useless. And there seems to be this strange apprehension that these tools do the job of a tester. No, they don't. What they do is they do the part of testing that frees up your resources because it's repetitive and is prone to error, and it makes your whole testing process far more efficient. It also allows you to do continuous testing instead of having to save your resources for a testing element. Even that fact alone, doing continuous testing using automated testing tools is one of the best benefits of the entire continuous integration process. It's a quality assurance thing. You're able to start picking up errors early on in the process before they make it out onto the customer's desktop. So the whole idea of test automation tools is to integrate what testers do into the test process. So now what we're really doing is we can kind of put this up into a little bit more detail and say we tend to operate under this paradigm of continuous assessment. So every time somebody checks code in, we unit test it. Every time somebody does a build, we functional test it. Every time it's deployed out there, we do maybe a beta test, a stress test. And we're always continuing to monitor what's going on in the field, and which could be sort of an acceptance test. So built into this entire process is this notion of continuous quality, continuous testing. And this is really important because I think most organizations would agree that testing and quality are always an ongoing challenge. So now we have an opportunity to do this. We see these tools deployed in a number of different ways. So, for example, we don't have to actually use the tools. Here's an example of a continuous integration and delivery in the cloud, the AWS cloud. All the major cloud providers have an opportunity to build these pipelines to automate all of the code delivery. So you can go to Amazon or Azure, and you can basically start there and say, okay, let's build our CI/CD process, and you never even have to buy another piece of software and deploy it on your site. Now, I'm not going to go into what all these kinds of things are. It's kind of irrelevant. But what we just noticed here, here's Jenkins, so we can actually have Jenkins in the cloud, and we can have we can do various kinds of testings and other kinds of things as well. That would be in our pipeline. So in committing code, and we get a trigger. So we've got all kinds of ways to implement these things. So the tool sets are varied, and there's many options. That just goes to show that you're not necessarily confined to going out and having to invest in a whole bunch of tools. You can take this whole thing into the cloud. Well, what do you do once you've built this thing? You got to put it somewhere before you can be deployed. So generally we talk about artifactory services. And what artifactory services are is once we've gone through the process of building stuff, there's got to be a staging area between the integration and there we built it, it works, it's tested. Well, where do we put it now? We haven't deployed it yet, so we generally create things called repositories. And normally the build tools will put stuff into the repository. It's like a warehouse. We're going to stage it in there. And JFrog is one of the ones that a lot of people really enjoy. and it's called an Artifactory repository. And you can see version control, build tools, CI work together, and the output of that goes into the JFrog Artifactory, and then the deployment tools would generally pick up the containers or the applications out of the repository and deploy them into the environment. So we do have this opportunity to basically warehouse our results of our integration process. Okay, so now we've got these tools. How do we get it out there? So now we'll just take a quick look at the deployment aspect of it. How do you deploy this stuff once it's in this in a repository? Well, this is where we get into a concept called infrastructure as code. And Ansible, just like Chef and Puppet, Ansible is one of the most popular ones right now. It's called a configuration management tool. And what it does is there is a controller node, and it has what we call playbooks, which are basically descriptions of what software should be running on which machine. It has a list of all of the different machines that are out there. And it says if I'm running, so for example, if I'm in a large organization and I want to have a standard set of software on all my machines, I could write a playbook which would go out and install the exact software on the right machines at the right versions. And what Ansible does is it executes the playbook and goes out all to the machines and say, are they up to date with where they should be? If they're not, we'll bring them up to date. We also have playbooks that allow us to put machines back to a previous state, revert things if things aren't going well. So the idea here is that we don't have somebody walking around from office to office with a CD drive, plugging it into the computer, or even people taking it off a network drive and running an install program. It all happens in the background. So Ansible is an example of infrastructure as code. And again, because the Ansible playbook contains a description of what needs to be deployed, how it should be deployed, and where it is, it's code. But when you execute that code, then what happens is Ansible goes and creates that infrastructure based on the specifications in the code. Kind of easy. For example, if you decide your organization is going to migrate from version 7 of a database to version 8, you can write an Ansible playbook that goes out and finds every server on your network that's running version 7 and does a update to version 8, provided it's on the approved list. So this tool alone solves a number of the problems. And like I said, it's not the only one. There's Chef, there's Puppet, there's SaltStack, there's a whole bunch of others. And the only reason I'm really focusing on Ansible is that it's the one that's just exploding in popularity because it's open source and because you don't need to run anything on other people's machines in order for Ansible to do work. It kind of sneaks into the machine, works, and then leaves like one of Santa's elves sneaking into your house at night with the Tooth Fairy. So you don't even know it's there until you notice, ooh, I've got new software on my machine. Well, once we've got all of the stuff installed, we have to ask ourselves, does it work? So this is where we get into this continuous operation. And so we've got Nagios, and this is just one, this is a popular one of a number of what we call monitoring tools. We install a little program on the various machines, and they give us continuous reporting on how the machine is functioning. Here's a sample of a machine here. And it's telling us about memory and CPU load and drive space. And also you can tell it's got some critical statuses here. So we're able to monitor and say, oh, our system's not working properly. Maybe have to reboot this machine over here. And we also can have various kinds of analyzer tools which will take all of this information that gets logged, and we can analyze it to figure out what is the problems that we're having. Why does the office in Dallas seem to always be down? Let's go back and look at the Nagios logs and figure it out. Oh, here's the problem. Somebody thinks they have to unplug the internet every night. That's maybe the problem. So let's go and take a look at that. So the idea here is that we have completely automated two of the really tedious, error-prone parts of the process of continuous delivery. The actual getting the software onto the machines and then confirming to see that the software is working or the machine is working as it should. I was mentioning in terms of monitoring machines, but this also can monitor the health of various software packages on the machine. And of course, my senior engineer can go home now, and he doesn't have to worry about it because he doesn't have to sit there and watch the screen. He just has to get that SMS message, that ping from Nagios, which can send him a message saying, hey, I got a problem, and then only respond to messages as they occur. We come back to our DevOps loop again. Okay, so now we've got the situation where we have a number of tasks which are representative of the application lifecycle management. We do the creative part of writing the code. And by the way, you can apply this to something as like writing a proposal. You have a number of people writing a proposal. Each one is writing a chapter. They've got their own repository and version control. And then we can do something like GitHub, and they can all push their chapter up to GitHub, and GitHub will do an integration and say, okay, we're great. Now the build tool might be to take everybody's different Word documents and images and build a PDF file from it. And then that PDF file has gone through the build phase. It may go to some kind of proofreading phase, in which we have grammar checkers and spell checkers going through it, ensuring, or analytics to make sure that at least it appears to be English and is understandable, maybe assessing the grade level. And then we might also put it into a queue where somebody's going to proofread samples of it. Okay, so there's the idea of we can apply these concepts to anything, not just writing code, but we really do get most of our benefit from writing code. Well, let's suppose we've actually got our proposal written, and then what we do is we send it out to all of the people that need to read it, and so that would be our continuous deployment. And we might say, we're going to send you updates on the proposal. You guys keep telling us if you have new requirements, and we'll update the proposal and send it to you. So we're going to deploy the proposal that's from everybody. We deploy it, and they read it, and then they give us feedback, and they said, okay, guys, 3 new requirements. We plan, we build, and we go through the same process. The idea here is that this process is a more general process than DevOps or Agile or even software development, although it is those processes that have benefited the most from continuous integration of delivery. So this is the kind of a general high-level view of what's going on in the industry, or what this automation is all about. So I'm going to make a couple of observations at the end, and then we'll open things up to questions. The first observation I'm going to make is that it's the old saying from years ago in the computer world, garbage in, garbage out, applies to continuous integration and continuous deployment or continuous delivery. I have heard many clients say, our software development process is a mess. Well, we'll just buy a bunch of tools, automate the thing, and all our problems will go away. No, it's not going to happen. You're going to go into the Mitch Hedberg thing, and you're going to suddenly realize I've automated a terrible process, and suddenly I've destroyed everything, because computers can destroy things much faster than my people can do it manually. So the first thing you have to do is to say, be honest and say, what is the state of my process? Where are our pain points? What are the problems we're having? Do we even have a process? And if we don't, then maybe the opportunity to automate will give us an opportunity to really sit down and re-engineer a process that we can automate. The other thing you might have is to say, we've got a pretty good process, and let's look at the places where our process is really failing us. Where are, again, our pain points? Where are people dropping the ball? And let's maybe look at automating those places first. And maybe we'll change some of the process to make it more amenable to automation. And that might not be a big change. It might be a little bit bigger than you'd hope for, so you might have to do it incrementally. But the first step is always, what is my process? What am I automating? And what are the actual benefits I'm going to get? And what are the deficiencies in my process that I can correct and then deploy in an automated environment? The second thing you want to do is you want to be judicious in your use of tools. Every single tool vendor will tell you their tool is the greatest thing that's ever existed. I actually listened to one vendor tell us that if we installed their automation tools, the software would literally write itself and we would never have to worry about it again. Unfortunately, he said that to a group of developers, and he basically realized that they weren't believing him when the room was filled with howls of laughter and fingers pointing and people saying, can you believe what he just said? So this is one of the other things we have to get in mind, is that tools automate what you do. if you do garbage, you get automated garbage. So what you have to do is make sure that your people are doing the jobs right, and no specific tool is going to save you. Tools have to be chosen on the basis of your requirements. What kind of code are you writing? What kind of clients are you deploying to? What kind of environments are we working with? And then you make the choice of the tool saying, this is the process I want to automate. This is the environment I have to automate it in. What are the tools that fit into that environment and that process? And that big, long screen of tools suddenly starts to become an awful lot smaller. But they're going to come down to several basic categories: the collaboration tools, the build tools, the quality assurance and testing tools, the storage tools, the repositories, and the deployment tools and the monitoring tools, all of which are tied together through some kind of high-level orchestration manager. And there's a lot of choices out there that you can make on those tools. But those choices become a lot easier when you really know exactly what it is that you're automating before you go out and start investing in automation. What's the other approach to take? Start small. Don't try and automate the entire enterprise. Never works. There's an old saying in cybernetics: you can't build a complex system from scratch. It always breaks. And Grady Bush would point out, yeah, that's because it's industrial strength software. It's just too big. So you choose your targets. You take pilot plans. In that quote from cybernetics goes, the only way to build a large complex system is to build small, simple systems that work, and then combine them together to build a more complicated system. So when we're looking at these things, one of the things you don't want to do is to say, okay, as of tomorrow, the entire organization is going on to GitHub, and we're all going to use Git repositories. That's pretty much asking for a recipe for disaster. You want to actually scope out a small scale project, because as you're doing it, you may suddenly discover, wow, there's a lot of stuff going on here we didn't realize was actually happening. We're going to have to stop and rethink this. Your risk is low, but you get lessons that you can learn from and leverage as you go bigger. The other thing you want to remember is that don't get caught into vendor lock-in. Don't think that just because you've always used Git and GitHub, you have to always use Git and GitHub. I mention it because it's the most popular. There's BitLab. There's a whole bunch of other repository tools that are out there. Maybe one of them is a better fit for what you're doing. So take your time, evaluate what's going on. And it might also be useful to see if any of your clients and competitors or vendors have in fact embarked on a single process. See what kinds of tools they're using and what their opinion is. Very often when I go to my client site, they say, yeah, we're using this source code repository tool. And I said, great, how's it working out for you? And they said, we wish we'd never done it. This is one of the worst tools. It's always down. It never works. Okay, well, thanks for that heads up. I think we might not be doing that. Okay, so what we're going to be doing is take it into questions and summarize once again. Know your process. Make sure your process is worth automating. Start small. Choose small projects. Choose your targets. And then use your feedback. Make your tools appropriate for your circumstances. And measure, measure, measure. So I'm going to open up the floor to questions. So if there's any questions, you can fire them away in the chat. I think, Paul, you might be able to relay some of them to me. Okay, I see a couple in here. Okay. So Richard, citizen development, I'm not sure what you're referring to there. Does anybody have any questions or comments? I'm always curious to hear about what people do, what their experiences are with automation, and how that's affected their organization, some of the things that they may or may not have positive experiences with or negative experiences. I just find the whole process actually quite more fascinating. So I think what was meant by citizen development, if I'm not mistaken, is getting tools that can be used by non-technical people to get the job done. citizen developers, quants, data scientists building models on their desktop using various kinds of automation tools. So I would say that yes. Okay, thank you. So I would say that one of the things that you want to think about in this is that when you have people who are specialists or SMEs in some areas, you want to not have them do the heavy lifting of managing the process. So it's a really good idea if you can somehow automate how they interact with the rest of the system. Like, where do the data models go? So there's got to be something there that moves their data models into a repository so they don't have to figure out, well, where is that data model? What did we do with it? So that's certainly a consideration. Yes, I would say there's a really, really good case here to build things like the data model repository. So as they build it, the repositories are built up. They're saved right to the models. Excellent point. I did think about that for a moment. Business users that want to deploy code. Yeah, one of the things too is that one of the headaches I used to have was I had developers who used to say, my computer's broken. And I say, why? They say, well, I installed these tools. And I would think to myself, why did you install those tools? He said, well, they looked cool. Okay, so we had to put rules about, no, we want you to only, if you want something, tell us, and we will tell you if you can install it. And if you can install it, we will install it for you. So generally, this goes back to the idea of the three most scary things in the world are a programmer with a soldering iron, a hardware engineer with a software patch, and a client who's got a technical solution they want you to deploy. So what we want to be able to do is when we talk about business users that want to deploy code, we want to put them into some kind of sandbox so that they're not going to deploy things into production environments, and we get them into a process as well. In other words, we take control of that process. We don't let people do end runs and say, gosh, our whole database is down. All I did was, and then you kind of count to 10 before you answer that particular question. Would it be good to learn Ansible? I would say that if you are going to learn any one of these configuration management tools, Ansible is the leader on the pack. It's clean, it's elegant, it installs without having to go and put software on all the machines in your system. All you have to do is make sure Python's installed on the machines. And I would say if you are going to learn any one of these configuration tools, I would say Ansible, simply because it's exploding in popularity because it is so efficient and so easy to use. Any recommendations for a non-programmer to begin on this? That's a good question. And I would say one of the unfortunate things we don't have is a lot of resources for people who aren't programmers, because these tools are built by programmers, so they write all their documentation and use cases for programmers. I would suggest that you might want to start looking at thinking in terms of a document instead of source code, and then taking a look at something like GitHub as a document repository and seeing how that works in terms of an automation process without having to think about code, but maybe work on things like Word documents and spreadsheets in a GitHub repository that your team might share. That might be an interesting situation to start with. Okay, have tools like Docker replaced the main purpose of Ansible since you can define the whole image? No, they haven't. They actually work really, really well together. What happens is that Docker, for those of you who don't know it, they're little kind of self-contained applications that get deployed in what's called containers. And this is kind of the wave of the future, and everybody's using these containerized applications. What happens is Ansible can be used to ensure that the appropriate Docker containers, it just treats Docker containers as another thing to be configured on the machine. So if you have a lot of Docker containers and you have a containerization solution, Ansible can ensure that it's deployed out onto your machines in the appropriate thing. So yeah, Ansible and Docker, they work nicely together. But you are right about one thing. Containerization is starting to move the focus away from the actual physical hardware and worrying about what's on the machine to talking about what's my containerization environment. So that is actually a very excellent point. So they haven't replaced it, but they've had to. But Ansible has to expand it in order its operations in order to encompass it, because it's still part of configuration management.
We are Starweaver, education you can bank on. For more information, contact us.